Hello everyone. This is a presentation of Mr. Sivakumar Shanmugam from Werner Enterprises who presented on Enterprise I.
Topic we are going to discuss today is, lately I was more interested in AI and machine learning, and I'm focusing more on how the data is huge volume of data is sitting around everywhere, and trying to do how we can do basically machine learning the data, and do some predictive analysis and predict what's going to happen. Those kind of the thought process I'm putting together, and do some analysis on the topic. So do you folks have any idea on that? I know you guys are enterprise architects, but did you do any machine learning and those areas? You have any expertise on that, or
No, I don't have any experience in that side.
No machine learning, and in fact,
We have
data warehouse DBA on site.
Okay.
Yeah. I put the government side, right? So we're not in that kind of cutting edge technologies.
Sure. And Krishna, I think the way you look at, are you in a Midwest area, or you're in a where do you live?
Actually, me and Suresh, we were same place, Washington DC area.
Oh, DC. Okay, got it. Okay.
Yeah.
Good. Okay.
I just came for vacation.
Sure.
For a month.
Yeah, I used to live in upstate New York when I came, and I used to work for like almost 4 years in IBM. 2 years
okay.
Upstate Poughkeepsie, New York, and then that's where I met Ganesh.
Mm-hmm.
We used to work together when I was in IBM, and then I moved to North Carolina, Raleigh, in 2000. So I worked there for 2 years, and then I came back, in Midwest. It's been almost. Okay, so quickly I'll start. Just going through. So let me share my screen. Hold on. Okay, so do you see my screen?
It's coming. Yes.
You see, right? Okay.
Yes.
So yeah. I'll just go through some slides at the end. I will show you that what I did, we did with the data, and maybe that will kind of help you guys to understand what I'm talking about. And again, this is applicable to any environment, right? Any database, any environment. So the idea is, this is the one thing I presented in our work also a while back, and also a couple of conferences. I went through this. So the topic is the AI and machine learning in the database world, right? That's
one question. So Werner Enterprise is your company?
Yes.
Okay.
That's what I work for right now. So I'll give you a quick introduction about our company too. While going through this, and anytime if you guys have any, this is going to be like interactive. Stop me anywhere if you have any questions, or if you have anything to be added. Just feel free to stop me. And let's have like interactive action, right?
Sure, we'll do.
Okay. So just to go through, so about Werner, right? So we are one of the largest carrier in Midwest America, and we have almost 8,000 trucks and 45,000 trailer, and we haul loads, truckloads we have a business in US, one of the largest carrier again. And yes, and then you might have seen in the road, right? The road, like blue trucks, it says Werner. And we operate in US, Mexico, and Canada. And we used to do like international business too, but right now we are more concentrating on the Mexico, Canada, and within US. It's all about us and our turnover. And just quick history, we started in 1950. That's our CL Werner. He bought his one truck, right? It's one truck, and then start hauling the load. And basically, he loaned his car for a truck, and then he bought a small, truck, and then he started hauling loads. And then today, it went to in 2020. Ours is like 2.2 billion turnover per year. One of the largest and carriers. And we went through a long way, between 1950 and 2020. Okay, so the quick agenda for today is just an intro. Just going to cover what is AI and machine learning, and deep DL is meant for deep learning. And I'll just give some idea of machine learning types and steps. What are the steps usually we do in machine learning? And you can see that comparing the traditional process of machine learning, and then I'll be focusing more on how we can do that in database machine learning, which is a new process all the database vendors are introducing. So supporting databases, again we'll talk about. I believe the Sybase is in the list, but let me find out more on that. And then second part, part two, we'll do a predictive maintenance optimization of truck fleet data set, right? So which we went through collecting some data set and how we ran the predictive analysis for truck data. And then what is next, right? What are the other areas we can do this predictive analysis? And I'm more focusing on I'll give you one quick demo on the sense the results at what we did from the data, and then we can go for a QA, right? Yes, sir. Any question?
No, I'm good.
Okay. So if you look at the AI versus machine learning, say the AI is umbrella, right? It's a bigger umbrella, wherein machine to imitate the intelligence of human behavior, right? So basically, you're introducing intelligence to a bigger machine, the entire operations basically. So that's what. When you look at machine learning, this is a subset. When you say machine learning, is a subset of artificial intelligence within that. So all we are doing is teaching a machine, right? Allows the system to automatically learn and improve from experience. So we are making the machine to learn based on the past or the set of data set, and then based on that data set, we can do the future, how that data is going to behave in future. So more like you can think about more like a probability, right? Statistics. We are introducing more statistical components to the data, and from there we'll be predicting what will be the outcome in future, data set. So that's kind of and again, in the machine learning process, at no point we will reach 100%, right? This all prediction. So anything you reach from 90%, 90 to 95% is more accurate, and then you can use the data set for for your analysis. And when you look at deep learning, anybody says deep learning, this is again subset of machine learning process, wherein application of the machine learning that uses you're putting complex algorithms and deep neural nets to train a model. So when deep learning is more robust within that machine learning process. So that's a subset of, you can say, machine learning. So for today's discussion, I'm focusing more on machine learning process, and I will explain what are the types and how significant it can help in any industry. So quick definition of machine learning, Arthur Samuel, right? He wrote in 90. It's nothing new. I mean, right now machine learning is more like everybody's talking about machine learning, but it's nothing new. It's in 1959. He basically wrote field of study that gives computers the ability to learn without being explicitly programmed, right? I mean, so it's sitting there for last 80 years, but more focus is happening in the last 10 years or so. That's why we are concentrating more on that, building more robust algorithm and doing more complicated, analysis. So quick thing is machine learning objectives. So the objective is a simple, a couple of objectives. So classify data. Basically, we are going to classify the data based on models, right? So there are various models I will explain. And then you need to basically select based on your data set and based on your labeling. I'll go through all these things in detail, but based on data set, you can classify the models. And prediction, right? The idea is how do we predict based on that for the future outcomes. That's the kind of two objectives for these are the two main objectives for that machine learning process. And if you look at the types, pretty simple. There are classify that machine learning the two different types. One is supervised learning, and another is unsupervised. And supervised, basically, again classified turned into two different things: classification and regression. And when you go to unsupervised learning, that's basically clustering algorithm, right? And that's where when you look at clustering, that's where more like a deep learning process come into picture. So deep learning we can always correlated to unsupervised learning, and whereas supervised, there are like two types. I mean, classification and regression. And for today's discussion, we will be more focusing on supervised learning, right? So if you look at a class, anybody doing machine learning steps, so these are the 6 major steps. Basically, the first thing is collecting data set from various sources, and then through an ETL process, right? Clean the data based on your data set, what you're looking for. You need to clean the data, and then explore the data set for basically what kind of, how many what are the null values, what's the max, min, and doing like a summary, basically doing a analysis, right? Analyze the data set, what you have. So exploring that, visualize, and then building a model, right? Based on the data set, you will build a model, and then evaluate the model and deploy, right? These are basically, these are the classic steps any machine learning process goes through. And then when I say that deploy step, once you deploy, the model is deployed, and then any new data set will go through the model, and model is basically the brain. It will tell that the incoming data set can be, what is the outcome. For example, if it is a true or false, like a naive Bayes, we'll go through a naive Bayes. Or if you have like a analysis, like a regression analysis, this thing, logistic or linear regression, where we go through based on that integer, like a data set, find out for I'll give you a significant example. Is you have a car sale, right? You have a car sale data set you have, and based on the last 10 years sale, and based on the car type, you can predict in the future if this particular car, a particular year, if it matches those kind of scenario, you will get this much, you can sell it for this much money, and kind of, right? I mean, those are the, and also this when I said naive Bayes or true or false, you have that wherein the data set is coming, and like the example I'm going to show of like a maintenance, right? We have a large variable data set for a truck, like a sensor data set we are collecting, wherein we have a temperature, heat, engine temperature, vibration, and all these things, a lot coming from the truck sensor data. From there we can predict like if the truck requires a maintenance or not, right? I mean, whenever we know that whenever we drive and our dashboard blinks for a maintenance requirement, right? So that's a kind of autonomic coming from computers. But here what we want to do is based on this data set, or like a truck tire tread analysis, and our battery, anything. If you have the right data set, you can predict that hey, trucks needs to go to a maintenance, or it can still drive for more distance, right? Those are things. So if you look at the current traditional architecture, this is kind of a process wherein you collect the data set from incoming text data, or whatever the data is coming from. You pipe it through a Kafka process, streaming the data set, and then process through basically Spark streaming, wherein traditional the way of that's where the machine learning models are built in. And then use that map, JSON, NoSQL map or database, like a JSON data set. You store it there, and then use various like a Spark SQL or Apache drill. Use them to drill the data set and do some analysis, right? It's kind of how I'm saying that initial step: data, collect, process, store, and analyze steps. A traditional way of sending the data. So, for example, if you have a right now data set is sitting in a Sybase or DB2 or Oracle or anywhere, so again you need to go through these kind of 1, 2, 3, 4, 5 steps to do some machine learning model and do predictive analysis. And this is the traditional step. Now just jumping onto the in-database machine learning, and if you look at it, all that database vendors right now they're doing is keeping the data set in the database, wherein the AI they're building, the database itself is built in with the AI layer, right? So what's happening is the data and the AI are merged together. So whatever the steps I'm showing here, you don't need to go through any steps. You just build your model. I mean, keep the data set on the same database, and you don't move anything. But still, you can do using that whatever that the AI layer provided by database vendor. You can do predictive analysis. So that's what I'm going to show you in this.
Just 1 second, if you don't mind.
Yeah.
So I just wanted to find out, like, basically in the AI, right? Just you need to. How do you define? I mean, how do you create that model to fit your database? I mean, is it like generic models you have available, or like you need to customize those models to fit your needs? How does that like database and model work? Yeah,
that's a very good question, Suresh, right?
Krishna.
Sorry, Krishna. That's a very good question, Krishna. I mean, I'll be showing you.
We'll go. Okay. I just want to know.
Sure. Yeah.
Because you said that, like, we don't have to create separate model and database, right? So we have to fit it together. So sometimes, like, so is there any specific customized models for the specific database? I mean, so models are depending on your algorithms, right? So that's why I was little.
That's what that's the beauty about this AI layer, where basically the model algorithm is already built, right? Algorithm is already built. All we are using is I will explain how that algorithm is going through a data set and doing the predictive analysis. I'll show you.
Sure.
You don't need to see the interesting stuff.
Too early to ask that question, I think, maybe.
No. This is a good question. I mean, you brought a good point. But the interesting point is, see, if you look at this complex setup, right? You need to know the various things. You need to be like an expert in Java. You need to know all this data streaming and the Kafka, and then Spark, wherein you need to be expertise in NoSQL, and there are a lot of things you need to be knowing in this setup. So wherein here, this is what interested me, because I'm a DBA. I don't need to worry about the Python, Java, or anything. No program. I don't need to worry about anything. Everything's kind of customized and built in within the database. And I'll show you how as a DBA, you can do run through the machine learning process.
And that means, like, do you, whatever the database available, the latest one, right? It's the integrated AI tools into it right now. Okay.
Correct. Exactly. Yeah. You need to basically, it's not supported in the older version, and I will tell you that I don't know about other version, but I'll tell you in the DB2 what is the version supported, and I'll explain the setup.
Okay. Basically, IBM itself create those models and integrate with part of the database.
Exactly.
Okay.
Yeah. IBM is provided, and
so if you want, like, if you want, you can create your own model and integrate it to the database also, right?
Correct.
So to fit your needs.
Yes. So you can use the IBM provided models, or you can use using Python if you are building your own models. Python and this thing. You can use IBM through database. You can call that external setup as a UDF, user defined functions, and call that as a separate, and then you can still use them, right? It's not limited to what IBM is giving, but you can still use external things too. User defined functions.
Sure. Thank you.
So, good questions. So this is what I'm trying to focus on more on why the AI machine layer, basically how that's going to help in doing that analysis on the in database. Okay, so this is what I'm just shopping for databases. I don't see Sybase here, but what I'm looking at is a database supporting databases: Vertica, Blazing, SQL, Google Cloud, BigQuery. It has supported, and then IBM DB2 warehouse, and that's what my focus is for today's presentation. And also Kinetica, SQL Server has that own supporting machine learning in database machine learning, and then Oracle, Amazon Redshift, right? Amazon Redshift, if you have that, then you can do it in AWS cloud, right? And the same thing, Microsoft SQL Server, if you have that in Azure platform, they have their own machine learning setup. So if you have a Microsoft SQL Server running on a SQL database, then if you want to do machine learning, so all you have to do is just invoke a couple of commands, and the database can be enabled for machine learning, and then you can do predictive analysis directly. So, but I will show you that in DB2 how we do, and then it will be applicable to the same architecture, similar process you can use. But different. When I said it's similar process, it will be similar, but you will be using different setup or different commands. So the why we are thinking about machine learning, right? In database machine learning, the benefits is the main challenge is the talent gap, right? I mean, because you need to know various Python and Azure or various things you need to be expertise in machine learning. But whereas with the data sitting in a database or DBMS, all you have to do is SQL interface, right? If you are expert in SQL as a DBA or any developers, they can do a machine learning deployment. And then say data sensitive data, like any PII data. If when you're trying to move from different areas, people will be like scared, right? It's scary. So whereas here data is not moving anywhere. Data sitting in the same database. So virtualized data access and model building, virtualized. And then there's no data transfer again. It's costly in that traditional way, and secure and scalable. And DB2 infrastructure, you can scale it, right? You can, if you any performance thing, you can scale the database horizontally or vertically. As long as you scale the database, you have more power, more CPU and memory, and you can build your model on the same, system. And DB2 scoring of DB2 native and open source models, you can use open source models too. And then again, everything's based on SQL based interface, right? Those are the main benefits. This is the current current survey says is 66%, right? I mean, we have a look at all the relational database. If you compare RDBMS and then no SQL, 66% of the data sitting in a relational data set, right? So everything sitting in RDBMS tables and table structure, and remaining 44, that's where we talk about all the unstructured data, which again, if you have unstructured data, as long as you are processing the data set and bring it to RDBMS, still you can bring it do it here, or you need to do a different way of analyzing. But we are focusing more on DB2 or Oracle or Microsoft SQL Server, wherein the data is in a structured within a table, RDBMS tables.
Shiva, the 66% is what is a generic in the whole world?
Yeah, it's a general number. I mean, the current survey says, entire the whole
data is stored in a relational database. Okay.
Yes, correct. Not like not for our company, just entire,
Oh, it's generic. Okay.
General number, yeah. So let's just deep dive into that machine learning model, right? Learning on DB2 platform. So, sorry, 1 second. Okay, sorry. So the DB2, when you look at this thing, right, machine learning process was introduced in 11.5.4, right? 11.5 fixed-back 4 onwards, IBM introduced machine learning process. So before that, if you have previous fixed-backs, it doesn't support. So only 11.5.4 onwards supporting. And when you look at these are kind of all the features I was showing, all the steps, right, in the evaluation: explore, pre-process, train the data set, evaluate, and interface. All this step, right, are covered in that covered through database IBM DB2. But what they did is they built a set of store procedures, right? We call IDAX procedures. And with that IDAX procedure, the store procedure, all you have to do is call your tables whatever you want to do, and then it does that magic. It does explore the data set, pre-process, train, and training. And in the train, that's where that in the train. When I said train, that's where you're building that model, right? Like a classification model, like a decision tree or naive Bayes, or you go through a regression. And then in the regression, right now IBM is supporting a linear regression, And a logistic, I don't see that yet. But if you are building a logistic regression, then again you need to build your own model. And clustering, again, for clustering, we use k-means clustering for that. Again, for all this in the train, whatever I'm showing red, pre-processed like a set of procedures are available, stored procedures are available. And then when you go to the evaluation, classification and regression, both ways, we can evaluate the model, and then you can build a confusion matrix, right? And basically, that's what the confusion matrix is, the where you see that how much data is matching with your with your test data set. When you try to run through the model and you already predicted some values, and then actual prediction, the actual how much is matching. And based on that, you use the data for the future, the model for the future, data sets. So let's just quickly jump onto that DB2 environment. So this is what this is the setup. We did it on a Linux environment. Again, right now, IBM, when I said DB2, we have AX and Linux, and this particular machine learning process supported only on Linux environment. AX still is not supporting, and IBM is still working on it. But with this setup, basically we did it on a Linux, and we are also trying to more focusing on Linux. And then from the AIX, we're trying to build an OpenShift and build a SUSE Linux environment, and from there we can set up a machine learning process. So the setup is pretty simple. The DB2 stop the instance, and then you have to set a registry variable DB2 enable ML procedures to yes. And then once you create the database, and then create table space, and then when you call a sys install objects, the IDAX, this kind of a setup I call, and basically in that MLTBSP, that's a table space. So once you give this thing, database creates a set of IDAX objects, right? Store procedures and set of tables to store that metadata plus models, basically model algorithms. It stores that, and then you give the permission to that table space to use the public. So this is the initial simple setup for setting up a machine learning model, basically because enabling the database for machine learning in this case. So the idea is, if you look at this picture, right, that truck data is coming from trucks. So engine failures and maintenance reminders, tire tread wear, a lot of data set, right? We are capturing so much data set coming through from a truck engine, capturing the data set and feeding into this 11.5.6 database. And from there, we are going to build the model. And once the model is built, and based on the new data set coming from truck, we can tell them, alert the driver, hey, do you need a maintenance, or your tread tire is tire tread is reaching the max limit. You go and change the tire. You have to halt the load, stop the load and go and fix it. Or battery is level is going down. Any maintenance, right? This is very important for us, because without this, we get into so many issues. Trucks can get into accidents, and which is very costly for us. Also, if you the load gets stuck, right? If you got the truck gets stuck somewhere, again, the loads doesn't get delivered on time, and you guys know that, right? What happens later? So the idea is on-time delivery, and without any accidents and all. Really, this process will really helps us.
Sure.
Yeah.
How do you collect the data? You have it says data from embedded sensors.
Yeah.
So the hardware will be situated. I'm sure there's a computer on the truck. So
Yes.
the truck collects all the data.
Mm-hmm.
So how is that data transferred to the system?
Yeah. So that's a good point. So what we do is, so we have a Qualcomm set up on the trucks, right?
Mm-hmm.
All the trucks, and we using the Qualcomm continuously feeding data to a legacy system. The AS400, we have a telematics setup, right?
Oh, okay.
Telematics, and then we have iSeries AS400. That's our basically our main system data feed coming, and all the trucks are all the through Qualcomm unit. we are sending, is capturing all the sensor data to like a truck location. We want to locate the truck where it is, right? Every it will ping the data set every based on the every 15 minutes or 5 minutes. It will continuously feeding the data through telematics to our environment.
System. Okay.
Yeah, our system, and then from there we pick up the data and doing a real-time replication.
That's great. So
Can you give me?
it's feeding real time, and the system you're reading real time will do everything. Oh, that's good.
Yeah. Can you give me 1 second? Just give me 1 second. Oh, sorry. Okay, go ahead. That's good. Okay. So, so telematics data is coming in. So through real-time replication, we feed the data to we basically use the replicate one. That's a replication tool. So from iSeries, we feed the data to a real-time data store, and then from there, we do that. We can do this analysis or predictive analysis. So the main data, as I said, the data is fed from a trucks to a database, right? In this case, I'm showing that directly DB2, but again, it's all up to us. We can feed it to a DB2 or a legacy AS foreign system anywhere, but real-time data will be reaching through from the trucks Qualcomm device into that, into the database, directly feeding to a database. So for this demo purpose, this is the data set we are talking about. So what I'm showing is a structure of a table, this table. So if you look at the maintenance flag, that's a label. That's basically a label data, wherein all other columns, right? Temperature, speed sensor, vibration, engine load, coolant temperature. I mean, a lot of stuff. If you look at it, all the GPS location, longitude, the set of data sets coming as a feature, right? So our idea is first thing you need to do is collect the data set initially and then label it, right? So if the data, I mean, more the okay, this is the point. I mean, first you need to collect the data and then run through your. There are so many tools available, right? And based on the data set, for our idea is that are based on the past experience, right? And we need to make that data label. If this vibration, engine load, engine temperature, all this based on the condition. If you had if the truck had a maintenance number, then mark it as maintenance. Yes, required. And the temperature is cool or cold, or emission is less, or some some other data set, different conditions. If that doesn't require a maintenance, it says make it no, right? Yes or no flag kind of thing. It's a flag column, or yes or no, or 1 or 0 in this case. So that's what you need to maintain get the maintenance flag. The rest of the columns are input values, future inputs. So first you need to have a set of data set for this exercise. So the data set example, this is how the data set looks like. These are the sample data set I'm showing, and last column is showing 0 for here, but we have like I believe over 7,000 rows, 500 rows, and some of the data set is 1, and some of them are 0, right? So what we did is we loaded the data set into a table, moved to table, and first thing is if you look at it, I'm just going through all the steps, right? Data exploration. So all you have to do is data exploration, first step. So that's a IDAX. So what I'm stored procedure I'm showing, that's all given by IBM. So I'll go and call the stored procedures in table. That fleet nav base is the into table set. Then output table set I will call like a fleet nav base summary, right? So once I do that, I'm just calling by simply the stored procedures. Boom, it builds that output table, nav based summary tables with the 7,500 row for what are the rows coming from input. And basically it's basically doing column profiling, right? It profiled the data set of each column and to tell you that what it stores in each column, how many nulls, and all the entire information about the table set data set. It explored there. So you can do exploration there. And then data transformation. So the transformation is the biggest thing, right? I mean, what we're doing here is we're splitting the data set. You want to, out of 7,504 rows, you want to know, you want to see how like suppose 95% of data set for training.
Sure. One second.
Yes.
You have this store procedure. So this is all a system procedure, right? It's not developed by the developers. It's from the
yeah. This is all IBM's. Whatever I'm storing store product, this is IBM's.
because as a Sybase guy, we have a system procedure. It's the same thing.
Correct. It's a system procedure. You're right.
We call it as sys dot blah blah blah. So it's an IDX. So this one, IDX is summary 1000. So this procedure will call this one and it gives the number of rows and the train, whatever it is, and model building, model size, and number of records and model development. So you have to feed something. So this is the code, right? That's a syntax.
So the code is simple, right? The code is a stored procedure.
Correct.
All I'm doing is I'm going in table equal to this, but it has to be in a certain format, right? You have to say in table equal to what is input table, out table equal to output table, right? So basically what it does is it goes back and builds a new table and take all the values from input table and then do a statistical analysis, gives the max, min, and how many nulls and the various. Basically, you're exploring the data set, right?
Okay.
So after running that first step, when you go to do a select start from fleet navy base, fleet navy base summary, select start from neighborhood, you will see all the summary information on the table.
Okay.
So that's kind of exploration on that. And so in this data transformation, the splitting data. So if you say in this case, in table is fleet navy base, right? And then you have a couple of things: train table and test table. You give the new table names, the same table name _train _test, and then you need to give that primary key on the table, which is ID equal to record ID, and then fraction, how much percentage of fraction. So what it does is, if you say in a 0.95 is 95%, so 95% of the data set will be stored in that fleet navy base train table. That basically we are splitting the data set into two, right? Split one for training. That's exactly we do in transformation process. Where initially model building, it split the data set into two, and 7,129 in this case 95% stored the train table, and then test is 375 records. Pretty straightforward. The model building in this case, as I said, IBM. We saw that, right? IBM has a so we have a decision tree, naive base under classification, and then regression, we have a linear regression. So in this case, since the true or false, we are using a naive base model. So based again, you need to be very careful where which kind of a model you need to use. And in this case, we are using a naive base. So IDAX naive base is readily available. So I call the IDAX naive base. Sending the model name, building a model. So putting a model name as fleet naive base, in this case, fleet naive base model, and then in table, the train table. In this case, I'm calling a train table which has 7,129 rows, and then record ID, target. Target is a maintenance flag. That is a label column, and then a couple of things: disk and bins. This is a pretty constant we use for the naive base. So some variables we are passing. So once you build this models, it comes with the model size 15292. That's the size of the model. And again, while doing all these things, I'm not doing anything. I'm not sending the data outside or inside. Everything I'm doing inside that database, right? That's the beauty about it. And then in the fourth step, I'm printing the model. So I'd ask call print model. So when I print the model, it will show you that how many zeros and ones, probably some what exactly the model stored, that information stored. And then you basically what I'm doing in that model deployment, basically predict _naive base. That's again given by IBM. So if you look at input values, fleet naive base model, that model name, right? Whatever I built in the previous step. And then in table, in this case, I'm sending the table as test _test, right? That's a data set which is initially I split the data in the split data process. So the test input will be test data, test table, and then record ID is the primary key, and then out table I'll call it as result table, right? So what I'm trying to do is, in this case, take the test data set which contains 375 rows, and see how many records, because the out for the 370 records, I already have the label column, right, populated, which is accurate value. I want to see how many records matched in this model that whatever the new model I built up. So there, again, I got 375 records output because the same number of records from the test table was processed. And last thing is the last step is the confusion matrix. When I build the confusion matrix, so again, the record test table, record ID, and maintenance flag, and then result table, result, and then matrix table, CMA matrix table, right? So when I do this, after doing this, when I do a comparison, right? How many real, how many matched. So basically, I got like out of 375 records, um, um, 236 are match. Is it yeah, 61 didn't match basically out of 375. 61 records. The model gave me a number different value than what the original value was. So that's a not match. So sorry, that is that is a percentage wise. It will like 16% difference, right? So that means my model is like a 84% accuracy, right? So this is the initial. So now if I use this model, confusion, whatever the model name, what is this? Fleet naive based model, and if I supply the future data set, data set, same kind of data set into the model, model will tell you that 84% of the time it will tell you that this is accurate to, you need a maintenance or not. And there are 16% of the time, if it falls in 16%, then it will say a wrong indication. But for us, since it's a trucking industry, wrong information is okay, right? If somebody says, "Hey, your truck need a maintenance," I mean, the situation is like this: if the truck doesn't require a maintenance, but it's still the maintenance flag is on, that's okay. That's like wrong. But the question is, if the truck doesn't require maintenance, truck require maintenance, but for some reason the indicator says it doesn't require maintenance, that's where the problem starts, right? That's a wrong condition. So that's where we need to tune the model to get more accurate data set. Again, you more and more data set, accurate data set, again, you'll be adding more data rows, right? More data to that training, and repeat the model building and make it like accurate to more, close accuracy, right? Close to 100%. And again, we will never reach 100%, but try to I mean, again, these are all probability, right? Probability and prediction. And any given time, we won't reach 100%, but there will be some discrepancies there. But majority of the time, it will match and then give that right warning.
Okay, so you said 84% something. So what is the threshold when some percentage comes, you think, hey, this truck needs the maintenance?
That's again, it falls under that model accuracy, right? I mean, because when I say 84%, where it falls in, right? If you look at the model, print model, the 7.79. So the model says 0.79 times I doesn't record a maintenance, and 0.20 I record a maintenance, right? That's what that model, based on the incoming data set, it predicts.
Right.
So
2.79, so that's okay. So we don't need a maintenance.
Yes. So what you have to do is you have to tune that. You have to again find out, add more conditions, adding more conditions where this truck requires a maintenance. Then again, you're increasing the number of ones, right?
Correct.
So if you increase the number of one, when the data set, incoming data set coming close to that value, then it will tell you, but in this case, you're right. In this case, 80% of the time, it will tell you no, because the incoming data set has 80% of the data set is 0, right?
So out of curiosity, it's generic. It's not only for your model.
Yeah.
So whole world, anywhere trucks are used. So there'll be some generic threshold. Let me say right now the maintenance flag, it says 0.79%. Let me say 0.8%, 80%, no. So that's okay, we think. If you see this is like 50-50, obviously you're going to say recommend for the maintenance, right?
Yes.
So what is the world standard or your standard? Like, hey, this person, it says maintenance, like 30% or 40%. If it touches that person, stop the truck and go for the complete maintenance. What percentage you follow?
Oh, okay. No. See, we are not looking at in this case, we are not looking at the percentage, but what we are looking at is the incoming data set coming in, right? We are sending it to when I send this data into the model again it has to go and does several retrain that, I mean rebuild that the data set, and it tells you go and stop the truck or don't stop the truck, right? I mean, based on model learns. Model has so many conditions based on that incoming columns. So it's not like a 50-50 or 80-20, but this 80-20 is I'm showing that model says 80% of the time I processed it, I built this model, right, based on the incoming data set, and the 80% I have zeros and then 20% I have ones. So that's what I have inside. But you give me the data set, and then based on that accuracy, I will what you trained me, what I will say, and I'll give you a number, right? Again, this is just a pure probability, whatever it's in the model. So it's not like a 50%. I mean, you cannot say that 50% or 40%. It's just how accurately you're building the model, right?
Okay.
And again, the test data set, again, in this case, test data we tested. So in this case, 84% again, as a data scientist, right? You'll come back and say, you know what, 84% is I cannot. I need to more accurate. So again, you need to collect more. Data set. That's collecting the data set is very important. That's where see that most of the time data scientists, if you look at any data science, they spend time in collecting data set. That's a time-consuming process. Once you collect the data sitting there, see, running through this process is pretty straightforward, and that's what I mean. Again, I won't say this is straightforward, but again, they are running through this process. If you look at the complex setup, you need to use all this. Go through all this hectic setup, right?
Right.
This entire stuff is simplified with IBM and any database vendors. They're simplified with this set of store procedure. So once you collect the data set, you call through this, and bingo, you got that result, right? So that's it. Again, this is applicable to any industry. You can be logistics, you can be banking or banking sector, or you're coming from marketing or any real estate, anything, right? You can use this for real. If you're in the real estate business, we call clustering, right? Clustering. We can use the K-means clustering model. Then you can do house price and what will based on this area, zone, zip code, state, county, and if you have all the variables data set, you can take and accurately predict what will be the house price if you're trying to sell the house, right? I mean, Zillow right now, Zillow is predicting, right? Same way, you can do some predictive model. It will closely tell you that in another 10 years, if you want to sell the house, how much you can sell it for. I'm just,
right.
Kind of. And this thing. And again, if you look at the predictive modeling, it's not only stops here. Again, these are kind of some examples, right? How long the truck can run without maintenance. So you can, based on the data, so you can tell. Or so we hire we constantly hire drivers, right? So we have like 10,000 drivers. We have 11,000 drivers. Every day we hire constantly 200 300 drivers, like a turnover. So our idea is, if you have the right data set, we can predict how many drivers are going to quit in the next 30 days. We can predict, and then accordingly we can do something. Try to retain them with a different gifts or salary, or I don't know. We can have so many factors with this. If you want to retain the drivers, we can do that. And company turnover in future, how much turnover right now, based on the past data set, you can predict how soon you'll be reaching future turnovers. Then prevent the accidents. Then as I said, the tire tread or battery life on the trucks. So these are some of the things. If you have the right data set, you can, again, I'm just looking for trucks, but it doesn't matter, right? I mean, it can be applicable to any.
Oh yeah, it can be applicable, as you said, for Zillow. It is for the real estate.
Yeah,
we are collecting airline data.
So airline, okay, awesome. So more like a larger, again, you have the logistics, right? I mean,
yeah, lot of airline, basically passengers and on time, because I work for DOT.
okay.
We are not doing for the like airline maintenance anything. It's like airline guys will be doing. For us, airline should be mandatorily provide data monthly.
Okay. Okay.
So like passengers on time, everything, and price, because they cannot take the monopoly in the market, because government is regulating, right? So
Mhm.
we get the data, and based on that we predict.
Correct.
See.
Okay.
Okay, go ahead. Please.
So the data, I mean, you're saying that not maintenance, but for like how many passengers kind of thing.
Yes, yes, yes. For example, Atlanta is the largest airport by
Mhm.
volume. So
Yes.
these kind of thing we do it.
Okay, got it. So you're collecting the data set to see like how many folks traveled in this area, and
Yes.
based on that, we last year and now, and you can
Mhm.
do like yeah, I hear you. So here is the point, right? That's a good point. So if you have that, see, these are the very good data set. If you have that, then you can constantly predict, right? You can say
Correct.
that last year, this, I mean, if you want to analyze last year, this year,
Yes, yes,
I mean,
yes.
I know the COVID time was kind of
Yeah, yeah,
crazy, but
yeah.
if you
That's
look at
right.
the regular number and the normal in the last 10 years, if you have the data set, and you can predict how much how many passengers will travel in next 10 years, right?
Yes, yes.
And then you
That's
can
right.
advise the DOT or whatever, you want to expand that airport, or you want to build a new terminal, who
Exactly.
knows. Yeah,
And
yeah, yeah.
this data we give is for public people, and airlines also take it.
Mhm.
And based on, for example, as you said, that we brought up the COVID point very nicely. Then, like we built a system.
Mhm.
Generally, what is that? Trend checks.
Okay.
They compare with the current month, the last month.
Mhm.
If it is plus or minus 20%, it's alarming. It's a warning. So data analyst goes, basically data scientists now, they call it data scientists themselves.
Yeah, yeah.
They
Mhm.
check, hey, this is something wrong.
Mhm.
So maybe the data is wrong, and they call this. But since this happened because of COVID, so don't know, because of COVID, there's a
Yeah,
drastic.
exception. So that's what we call exception data.
Yes,
These are like
it's
exception, right? I
data.
mean,
Yes,
it's not the
and
normal. Yeah, I hear you.
exactly. Yeah,
Yeah.
yeah, yeah. So based on that, the predict how much people travel from West Coast to East Coast,
Mhm.
and the whole year, which is the highest traffic time. So how they have to maintain the airport. This all
Got it.
they keep
For
this.
sure. Got it. Perfect. Yeah. So those are the good examples, right? I mean, yeah,
Yes.
the COVID was the not right thing, but at least you can during the COVID time, still you can predict based on the last January to November or December what happened, and then next
Yes.
month how many people will travel, and
Right.
kind of, yeah, those are the interesting thing, right? You can ask ourselves some questions and come up with
Yes.
yeah, that's a good point. Yeah. So you can do so many things, right, with this once you have that right. Again, I'm just showing this one examples from the DBT perspective, but again, this is not limited, right? You can do
Oh yeah.
anything.
The more the data, more lot of
Yeah.
analytical point, and like
Sure.
we call as a, before it used to call it a forecast. Now it is like
Mhm.
prediction,
Yeah.
machine level prediction. So which
Exactly.
more data we can tell, like time based, like
Time based.
after
Correct.
2 months what's going to happen, after 3 months what's going to happen.
Mm-hmm. And that's exactly executives wants, right? Management wants,
Yes.
and they
Yeah,
want
exactly.
to look at the, hey, give me I will send you the data, but you give me that
Yeah.
outcome. And more the accurate the model is, you can openly constantly tell them, hey, this is what happening, and this is what going to happen next month, and be cautious.
True.
And and then again, yeah. So this is one thing I was just doing for SQL Server, right? 2017, same way. What I'm showing DB2, similar way we can do in stored procedure call, and then build a data machine learning. And these are some of the things I was doing for a different data set, some sample data set I pulled from GitHub, and then like naive Bayes, linear regression. Again, these are like I'm just I did some example, and just to show you guys, these are the stored with, when I say IDAX left side, These are all like stored procedures, right? I was explaining that IDAX summary and then column property. There are that's what I showed you in that result, but still you can use column properties or get column list. There are set of procedures IBM is giving for data exploration. And then data transformation. I just use a split data set, which is I showed you in that example, but we can use impute data. Like if there is a missing null values, you can impute data using the proc. What do you want to convert into, right? Because we don't want to see any nulls. Data set comes in. You want to cleaning data set process, transformation. So these are all that stored procedure we can use to clean up the data. Standard STD form. I mean, again, a lot of things. I explored only few of them, but there are a lot of things, database vendors are giving. And model building, here I use only IDAX naive base, but again, you can use linear regression for linear regression, and then k-means for clustering, and growth deck tree. That's another decision tree hierarchical model. These are all, this is the main algorithm, right? Model building algorithm. Generated by, in this case, IBM. Then model tuning, you can use that for a decision tree. You can prune the data, you can clean up the data set using the prune tree, deck tree proc. And evaluation. So in this case, I used a confusion matrix, right, to build that to show how many records matched or not matched. But still, there are other procedures, C matrix stats or MEAE, MSC. These are all like more you'll be using for regression models. Then you can use this function to see how many, what is absolute mean, right, and the error and prediction stuff. And then model prediction, again using predict tree, predict k-means, predict linear regression, predict naive base, right? These are all like for predictive analysis. And in our case, we used predict naive base for applying the for the prediction.
Okay. Yeah. Yes or no. Right.
Yeah. Yes or no. Yeah. And so the predict naive base, you pass that input the model you built, and then find out how many matched or not. I mean.
Yeah, this is interesting because I see this one. Everybody does this one. For example, in our office, this all done by the analyst. They have their own program. They ask,
yes,
can you do this one based on their input? We create a store procedure for them, an application. They do it. Yeah. Now, this is very interesting. Like DB2, IBM brought up this one. And every table, as you say, like there is a primary key and there's very important key. Based on that, if you feed, like predictive analysis, you get yes or no. That's very interesting.
Correct. And again, it's not always, again, that's what we need to spend. I mean, it's not always yes or no, sometimes yes or no, sometimes for example, truck sale price or something, right?
Exactly.
Then you need to go through a linear regression. And then if it is like some weather data, if you have some weather data coming from different regions and the trucks are going through the weather. See, we basically constantly advise drivers to follow the weather.com, but still we follow the weather and say alert the drivers, right? There is a bad weather coming in. So in that case, we use that we can use that clustering, right?
Even it creates a summary table by itself, because generally I have in our data warehouse like a lot of summary tables.
Okay.
Like a couple of table we have about 1.3 billion rows.
Oh my God. Yeah. Okay. I hear you.
And that one we have a much summary table because that's a huge table. So the user, they don't want to go check, run everything. So we built a multiple summary tables based on that one. So now if I see this model, they have their own summary table. So what I see right now, I'm seeing from COBOL. I don't know, probably you would have studied from COBOL.
Yeah, COBOL, so in the Z, so you guys are using mainframe, right? Z series, right?
No, when I started in '94, we had in India IBM competitor Burroughs. I don't know whether you heard about it.
What is again? What is it again?
Burroughs mainframe.
Okay, Burroughs. Okay, got it.
Burroughs, IBM. They once upon a time they were competitor. Then it was bought by some other company. It's gone. So in that COBOL, basically mainframe, or it's a COBOL. I see simple database reading. It's so much painful. Then eventually I started learning Sybase. Then I say, oh, Sybase is select star. That's it.
Yeah. I know what I'm saying. Yeah.
So the thing is, to just a select star, you have to write
code, right?
I mean, just a select hello, you have to write a big code in COBOL. Then same thing was simplified into select in SQL language.
Yeah.
And now I see how things are evolving. We started creating our own summary table. Now the product itself, like which is called machine language. IBM is, I mean, basically this is what they're doing it. So you don't have to do the summary table.
Yes.
The story.
Very
interesting.
Yeah.
How it evolved. Evolved.
Yeah, we are evaluating. And if you look at, again, you are looking at that, again, if you look at NoSQL and JSON data set, right? In the future. Again, we are going back to that condition. I mean, that there you use NoSQL language, which is, again, a little complicated, but much faster though. I mean, you're storing the data set in a JSON in a single column with a document. Again, that's a different kind of architecture, but which is more, think about, you don't need a column. If suppose somebody is bringing a different kind of data, still you can store in the JSON and do some analysis instead.
Oh, yes.
In RDBMs, it's hectic, right? You have to add a column, drop a column, and again, it's all kind of a different kind of this thing. But you're right. I mean, we are kind of evolving.
Yes.
And maybe this is what we need in the next, But it's interesting. Once you start doing it, it's very interesting. And see, there's the architect or DBAs. Our main tasks are like we do the architecture, and then once you build the database and data, that's it. They forget us, right? I mean, nobody cares. I mean, BI people or analysts will be the leading, right? They will lead the data and talk to management. But now, if you are putting some interest and we know, we help them. We do a lot of things in the background, and we always say we are a DBAs are like a dark. They sit in the dark area, right? I mean, nobody, unless there is a problem, nobody look at us.
Yes.
But in this case, if you put a little bit effort above this thing, and then if you know these things, then you can do your own magic, and you can compete with I mean, nowadays that's what industry is leading to, right? I mean,
right.
So again, just I see my interest. I'm trying to shifting my focus slowly into AI and trying to be a data scientist, right? I mean, data science is interesting. How long you?
I am also doing the same thing right now.
Right, good. Yeah.
From the DBA now, I'm moving to the data engineering part.
Data engineering, okay, very nice. So, how long we can keep loading the data, unloading, loading, and keeping the data structure maintained? I mean, that's sort of interesting. But now more autonomic. There, IBM, all the database vendors, they're making more autonomic and more this thing. And the future is going to be, for the DBAs or architects, it's going to be like more like spending more time in analyzing and predicting data set, right? I mean,
right.
So again, that's what my interest is. When I was seeing this feature, I was just focusing more. When I learned this, then it gives me more interest, right? What you can do.
Very, very interesting. Yes.
Yeah. But I don't see Sybase here. But do you guys do you have anything with the Sybase? This
Sybase right now we are using Sybase IQ product, which is a big data basically. So what SAP guys are Sybase or SAP right now? It is SAP.
Okay.
They got the Sybase is bought by SAP.
Okay.
And they call it as big data SAP HANA with hybrid, which is mean HANA is in memory, but hybrid is what is HANA, right? Whole database runs in the in memory.
HANA, I saw that in that more like Hadoop and HANA, right? Is it?
Yes. Okay. And big data. So what SAP is doing hybrid is, suppose everything runs on the HANA, which is in memory. Suppose a machine crashes, it never saves. It's in the memory always. So what they do is they integrate with SAP IQ. IQ is a big data. It's a columnar database. So theoretically, it saves all in the back IQ
the data, the disk. Basically, even it crashes, the in-memory cleans the buffer, But still,
Yes,
the data is
from
stored in the
IQ,
disk.
yes.
Okay, got it.
So we have one, not HANA, but IQ and SAP AC, which is equivalent to Oracle database and SQL Server.
Okay, got it.
But SQL Server and Sybase are same, almost same syntaxes.
Okay. Sure. I agree.
I have to see, but right now what we are doing is they're planning to migrate from Sybase to SQL Server Azure.
Oh, okay.
Azure with ADF and Synapse.
Synapse. Oh, you're
So
going to
that's
Azure
why
Synapse.
I'm learning Azure right now.
Okay. Yeah, Azure Synapse is another big thing, right? For the data warehouse, and they have their own Azure Synapse. Or did you guys look at Snowflake?
No.
Snowflake. Okay. Snowflake is another data warehouse, right? I mean,
They started coming in, but Microsoft, their marketing is so huge.
Yes. They are kind of, yeah.
Yes. For example, that's what I used to, Ganesh is a very good friend of mine.
Mm-hmm.
He used to make fun, man, you left this guy, Bill Gates. He created his own company and he's killing your company.
Correct. I know. That's what's happening right now. Is but if you look at that way, say Azure, forget about Azure, right? That's what I used to also Ganesh too. I mean, when you look at Azure, yeah, it's a massive data center. They have all these things, but again, behind the screen, they have the machines are running, and somehow machines, I mean, IBM's Power Blade server, right? I mean, who knows? I mean, they have the
exactly. Microsoft. I like one thing about Microsoft is.
Mm-hmm.
They don't give up. They keep doing something else. That's what I always, whenever some users ask us,
mm-hmm.
I will always tell one. I had my colleague like, we have to do perfectly with our time. I say, we have to follow Microsoft. Just give them.
Mm-hmm.
Anyway, there'll be some bugs. They'll come back and we'll fix it. So Microsoft keep doing that. That's how, like, initially when Sybase is very good comparatively to Oracle also, but the thing is, Sybase never had a very good marketing team or anything like Oracle and Microsoft. But Microsoft, suddenly they invested a lot in new technologies, and more than new technology, the marketing is so good. Not even all the government sector right now, it's Microsoft, not even AWS.
Oh, is it? Okay, got it.
Oh, they straight away give free training for us.
Got it. That's how they capture the industry.
Yeah, one simple thing for them, I've seen the model is they give free training and they ask the client, say, hey, you have people around all over the place. You just install our software, you get the people cheaper.
Got it. Yeah, I know.
That's why Microsoft, like technology-wise, IBM's technology is so sophisticated, others, but Microsoft are good. But technology-wise, I would say they are far superior. But marketing-wise, these guys are very, very superior.
I know.
And IBM is it's not only superior, right? They make it complex products. That's the biggest problem with them.
Yeah. Complex and
not usable.
Not complex and a little robust, right?
Robust.
I mean,
IBM is very robust.
They think that robust, Shiva. The problem is when you come to the user perspective and also maintenance, those kind of things, right? It's it's like we stuck. We know where to go. Even the IBM in our VA in the government side, we have all the IBM products. They sold it IBM, the whole bus, right? Like middleware bus for they spent $100 million, and then we don't have. That's why they always make a joke about it. We have a super highway, but we have a bicycle to ride.
Yeah. That's
okay.
Yeah. They built like a mainframe and a mainframe. I mean, if you look at mainframe and other things, will never, that therefore still,
exactly.
I believe still in the government sector, folks are using mainframe, right? I mean,
no. That's so true. The problem with the VA, right? The contract got ended last year after 10-15 years. Okay, they spent $100 million and then nobody used it, and then it's wasted $100 million.
Got it. I know what I'm saying.
So that was a big for us. That's one of the example I'm just giving you when you compare the products, right?
I know. IBM some other things they give with more marketing and this thing, And as long as your setup is complex, you can use them, and it's very powerful. For especially the mainframe is. See, today nobody can beat the mainframe, but it has its own drawbacks, right? You need to.
Yeah, that's true. Even the even the Capital One, my wife works, they have all the credit cards we use, right? So they're moving to cloud now, completely to AWS. All of them, they're building an APIs like move away from mainframe.
On-prem mainframe. Okay, so all the mainframe technology is going somewhere.
It's just slowly it'll be gone one day.
I know that's it's everywhere. It's right now our industry, right? We are having that IBM mainframe I-series. That 400 is our main legacy system, and we are slowly sunsetting, and everything's going to Azure now. Azure, we have a mastermind.
See, it'll be a cycle. Now everybody's moving to Azure, right? And then slowly coming out of it.
Yes. Azure. I mean, and the future. I mean, if you look at the future, it's very. Sometimes I see all our kids and friends, right? They're doing they do computer science, computers, right? I don't know what's going to happen in future. I mean, future is like a call APIs.
Everything is APIs.
What are they going to do? I don't know. I mean, future is going to be a API driven process. Then you don't need to know anything about your code or structure or anything.
Yeah.
Call the API with some number. It will give you the result, and they use it in your dashboard.
Exactly. I mean, something is going to come up. See, the AI is there right now, right? Everybody's focusing on it.
Krishna, Shiva, it's 10:30 here.
Sorry.
Sure, sir. Yeah. Yes, Suresh.
Thank you very much, Shiva.
It's nice meeting you, Shiva. Okay, we'll bother you sometime if you have questions. Because the reason is we also doing I'm also in healthcare. Our phase is over already, data migration, we're trying to ingest and transform the data. We already did very complex data, 30 petabytes of data, imaging, we already have it. I mean, we will discuss later. You don't want to waste your time.
Okay? Sure. No worries. We'll explore and see. I just want to. We can always kind of chat with what kind of difficulties you guys are having.
Exactly. We'll chill. I mean, see, the problem is I'm not in the government side. I'm in the data side. So that's we are the enterprise, coming with the strategies and just provide solutions, those kind of things. Sure. So that's why I'm not involved in all your discussions. I don't want to interrupt you because I'm not that aware of those things yet. I mean, we know, and in high level, I know what it is, but Sure. I'm not a detailed person in the data side.
Good discussion. Thank you.
It's nice talking to you and nice meeting you, Shiva. Once I come back, maybe we'll chat some more time.
Sure. Thank you, Krishna, and see you, Madan.
Okay, thanks, Shiva. Thanks for
chatting. Madan is still here. Okay. Thanks, Madan.
Thanks, Krishna. Okay. Thanks a lot for the
insight. Bye-bye.
To get instant updates, follow us on our social media pages.